Okay, so one thing I wanted to go over was some homework that one of my online students turned in. Now, you guys remember the Christmas tree program from program problem 1.6, I think it was? Anyway, so this is what he turned in, right? Pretty crazy stuff, right? So I compile and I run. Looks awesome, looks amazing, okay? Now, like I just want to tell you guys, like I'm not a freaking idiot, okay? When I see work like this, I think the red flag goes off in my head, thinks, okay, this guy probably copied it from somewhere, right? Otherwise, he should probably be like in an advanced programming class. He's using arrays and he's using a lot of stuff. So really all I had to do was just, you know what, I'm gonna copy this first line right here, and I'm gonna paste this into Google, right? And like one of the very first results here is exactly what he did, okay? Like when I say I don't want you guys to cheat, like this is the kind of shit I'm talking about. Like this just makes me so angry. I feel like offended. Like he basically told me I was an idiot, you know? Like that's the way I feel. Like I'm not an idiot. Like when I look at everybody's code, I've been doing it for a long time. I know where things, like I know what's out there on the internet, okay? So I'm like, again, I'm not discouraging you from going to the tutor, from collaborating with people in this class, but when you turn in your work, you need to understand what it does. And when you turn in like advanced stuff like this that you copy and paste from the internet, like obviously it's gonna raise a red flag. All I had to do was like copy paste, and I was able to find the exact website that he copied it from, right? Like I'm withdrawing the student, right? If I catch anybody doing something like this blatantly obvious, like you will be withdrawn from the class, okay? So if you, like I know chapter 2 homework gets kind of hard because that's when the students, you know, start to drop, but like don't copy and paste anything blatantly off the internet, okay? Like make it difficult for me to guess that you're cheating, all right? Like we have plenty of opportunity to go to the tutoring lab. There's somebody there from what, 8 to, when does he leave? Anybody go to the tutoring lab?
There's a guy there from like noon to like 5.
Oh, really? I thought it was supposed to be like 9 to 5.
I don't know.
Like those are the hours.
There's a guy there for like the entire day.
Okay, well,
Except for like lunch. And
It-
it's super helpful.
okay, yeah, there's plenty of places you can go for help. I don't expect people to try to figure everything out on their own. Like if you're having a hard time, like get help somewhere, right? But just, I don't want you copying and pasting anything. When it comes to the test, you're actually gonna have to know what you're doing. When you come and tell me, demonstrate your code to me, you're actually gonna have to know what you're talking about, right? So it's a little easier, like maybe for the online student, they feel like they don't have to interact with me. So like maybe they think a little different where they're just like, you know what, I'm gonna submit this as my homework, done, don't put any thought into it. But when I see that, like, you know, like I'm gonna withdraw, like I put the same rules for them as I do you guys, except I don't have that one-on-one interaction, you know? But anyways, I just kind of wanted to bring that up. This is the first time anybody's ever cheated on the chapter 1 homework, right? That's the very first time that I've caught somebody cheating on chapter 1 homework. I've withdrawn students in the past, you know, for like stuff like this, but like nobody's ever cheated on chapter 1 homework, right? It was so simple, right? You just type stuff into system out print line. So yeah, so like, to me, it was obvious, like, he probably waited the last minute, copied the problems, pasted on in Google, and just grabbed whatever he could find, right? Instead of actually taking the time to learn how to do this stuff, okay? All right, you guys won't see anything like, well, actually, I take that back. You probably will see some of the stuff, chapter 5 and 6, but it's way advanced for chapter 1, okay? All right, so I just wanted to put that out there so you know, you're aware of what I look for. Okay. The other thing that I wanted to talk about was programming project 2.11. All right, so it is a little complicated. It's probably the most complicated problem from chapter 2. Okay, so I'm gonna go ahead and read. I'm gonna read this problem. All right, so it says write a program that prompts for and reads a double value representing a monetary amount. Then determine the fewest number of bills and coin needed to represent the amount, starting with the highest, assuming that the $10 bill is the max size needed. For example, if the user entered, or if the value entered is $47.63, then the program will output 4 tens, 1 5, 2 ones, 2 quarters, 1 dime, 0 nickels, and 3 pennies. Okay? Now, this is something, like I said, this is stuff that we do in our head all the time. It just gets complicated when you translate what we do in our head to an actual program. So one of the things that we teach here at Northwest Vista is using pseudocode. So pseudocode is the idea of just using programming and English together. There is no real definition of how pseudocode should be written, okay? But you write it in a way to where you're solving the problem without actually having to remember the syntax of the program that you're going to program in. Does that make sense? So you just kind of you're writing out the steps that it would take to solve this without actually having to write the program. Okay, so let's just think about this. All right, so I'm going to go ahead and just write some pseudocode. Let me see, what should I use? I guess I'll use Notepad++. All right, so right here, I'm going to, I guess maybe I'll just copy what the problem says. Oh dang, I put everything on one line. That sucks. All right, so all right, so that's just basically the problem that I just read. I just wanted to write it out that way I don't have to keep hopping back and forth. All right, so let's think of how we're actually going to solve this problem. Now, you could just start off right away with the things that you know, right? You don't necessarily have to do this, but I know some students like to put like a, import scanner, right? Like they know they're going to have to input the scanner, and they know how they have to create a scanner, right? And then some things that they start thinking, like, we're just gonna think about the things that we need, and we could go back and add things as we go. So we know we need the scanner, so we're gonna import it, create it, and then what we're gonna do next is we're going to prompt user for value, or we'll say like money value, okay? And then maybe we wanna say something like store value in amount, right? So this is me just typing straight English. Now some people like to do things like, it doesn't matter if you're familiar with the syntax of the program that you're writing for, you can say like amount is equal to, right, scanner next int or something like that. There's several ways that you can do this. Whatever you feel more comfortable with, because you're basically making notes to yourself on how you should program this program, right? Like you're just trying to figure out like how you're going to break down this value, okay? All right, so we're basically we're going to store this information that we get into this amount, okay? Now we know that we're going to need variables, so I'm going to come up over here and say we need variables for tens, fives, ones, quarters, nickels, or dimes, actually. Dimes, nickels, pennies, okay? So from this amount that we got, we're going to have to figure out what is my value of tens equal to, okay? So tens is like the number of tens, right? So tens is equal to the amount, right? With some mathematical equation applied to it, right? Or some mathematical work done to it. So if I had $47.63, how do I get the number of tens from that?
You divide it by 10 and take the remainder.
Well, actually, you won't take the remainder. You're gonna take
Or
the,
you're going to check.
you're gonna take the
check if
result.
The remainder is greater than 0.
No, you won't check if it's greater than 0. So I mean, what you would do is you're just gonna divide it by 10, right? If you do integer math, right, in Java, you're gonna drop off the remainder. So it's really simple. The number of tens is equal to the amount, right, divided by 10. Pretty simple, right? That's how I get my number of tens. Okay. So then what do you think the next step is? Let me put a bunch of space in here so I can scroll. All right. So I got my number of tens, right? That was pretty straightforward. That was the first amount. Now what do you think I need to do?
So it'd be remaining amount.
Remaining amount, that's a good variable. I think maybe we should go up here and declare a variable. It's gonna have to be a double because it tells you to use a double for the amount. So here we're gonna have variable for amount and variable for remaining. Okay? After you divide it by 10, what is the remaining gonna be equal to? Okay, so it'd be actually be like the amount percent 10, right? That's the way we get the remainder in Java. Pretty straightforward, right? Seems like a really complicated problem, but I got the number of tens, and now in the remainder, I'm gonna have, if it was $47.63, I'm gonna have 7.63. Excuse me, 7.63. Okay. Now, how would I get my fives? Remaining. Okay, so this is where students kind of trip up. They think they got to use amount again, but we don't want to like modify our amount because we want to be able to like retain the initial amount that the user entered, right? We could say you entered $47.63. That's for 4 tens, this many fives, this many ones, this many quarters, right? So now we're just going to work off of the remaining, right? So same thing. How do I get the number of fives from remaining? 5, right? Pretty straightforward. And then the remaining is going to go into the amount. Oop, I'm sorry, you're right. Yeah, good catch. I made the mistake that other students make. All right, so like I don't have to worry about amount anymore. Now I'm just working with the remaining, right? I pulled off the number of fives. Now how do I get my number of ones? Right? You don't necessarily have to divide by 1, but if it helps you to have that consistency, then you're going to have to divide by 1, right? And then remaining, we'll just say is whatever the, actually I guess you would have to divide because you're trying to convert this to an integer. Now when we actually do the code, we're going to go from double to int. We're going to have to convert this to an integer so that we lose the fractional part whenever we're trying to pull off the number of dollar bills that we're taking off. Okay, and I'll show you that when I do the code example. All right, good, right? I can keep going. And I don't know, some students seem to get confused when they get to quarters because it's a fractional and all that, but the math works just the same. It doesn't change, meaning doing this is gonna tell you how many quarters you're gonna have left over, right? In that amount. And then the remaining will just be the exact same thing. Remaining percent 0.25. Okay, pretty simple. Right, it's going to do the same thing. Like even though it's a fractional part, like some students kind of get confused because they're using a fraction, and I don't know what they're thinking, but.
It's more of a tedious program than a conference.
Yeah, and I mean, you just use over and over and over again. I pretty much did like, I mean, the idea is there. Like, you can solve it by just looking at that. Now, it is going to get a lot more complicated because if you read the coding standards, I do want you to not use literal values in your equations. So that means you're going to have to declare a constant for 10, a constant for 5, a constant for 1, a constant for 0.25. Okay? I don't want to see literal values in your equations. And then the other thing too is you want to do this math as an integer, but remaining is actually declared as a double. Okay. Yeah, you're gonna have to do that here as well. Okay, and that's pretty much it, right? Like that's pseudocode. We took out all the complexity of the syntax and we just sat down and we thought about how we would solve this mathematical problem without having to worry about like programming it. But now that we have like the pattern down, now we can hop over to Java and start creating this program based off of what I have here. Okay, so what I'm gonna do is I'm just gonna copy what I did here and I'm gonna make a new file. Actually, let me save this one. I'll put this in Dropbox. Let me see. So under demos, chapter 2, I'll call this one pseudocode. And I'll say like PP 2.11. Save it. And then I'm going to make a new Java file. I'm going to call it money counter, I guess. And it's going to be Java source file. Save it. And just so I know what programming problem this is for, up here I'm going to put 2.11. Okay, and I'm just going to copy everything I did for my pseudocode into this Java file. All right, I'm going to work with what I have, what I put here, so they can have a reminder of myself of what to do. So up here, I need to import java.util.scanner. Got to remember there's a semicolon that goes there, and then we have to create a class, the main method, and all that stuff. So I'm going to go ahead and do that here. So public class money counter, public static void main string array arguments. Okay, and I'm just gonna like slap in all this stuff over here. Okay, I'm gonna just take it. Oh dang, what the heck. All right, I'm gonna just take it line by line. So like right here, I know I need my scanner. Right, and then right here I left a note. Maybe I can make the rest of this code comments, right? So variables for tens, 5, okay, so I need to declare those variables. I know I want them to be integers, so I'm gonna say tens. Actually, I don't want to do all of this. I'm just gonna copy what I did here. I declared my integers for the tens, fives, ones, quarters, dimes, nickels, pennies. I also noted that I need a double for the amount and for the remaining. I'm gonna go ahead and make that, and then here I have prompt the user for the money value. So I'll go ahead and make that a code comment. Okay, so I'm gonna say system.out.print. Enter a money value. All right, and then I'm gonna store that result into amount. I'll say scan.next double. So the problem did tell you when it is as a double. If you put a next int, you're gonna lose the fractional part of the input. Okay. All right. So now it's really just working, like just doing the math on all of this. So I'm gonna go ahead and just delete all this because I don't really need it. Okay. So my tens is going to be equal to my current amount divided by 10, right? And then just before I continue, I'm gonna go ahead and just like do this step by step. So I'm gonna go ahead and print out, make sure that the number of tens is correct. So I'm gonna say tens okay, so let's see what happens if I do that. Does anybody see anything wrong with what I just typed? Like they can see a future or problem when I go compile? No? All right, that's fine. Okay, was it parentheses? I don't know. Did I mess that up somewhere? Right, so this amount is double, and tens is an int. Double 64 bits with the fractional part. A 10's an integer with no fractional part, so there's going to be that loss of precision because I'm trying to convert a double to an integer. Right, Java's gonna get mad at me, so I'm gonna go and try to compile so you can see that error. So I'm gonna change the directory to Dropbox, wait, desktop, no. Dropbox, public. All right, so from here what I'm gonna do is I'm gonna say Java and the name of my program, I call it money counter. Okay, so incompatible types, possible loss of conversion from going from double to an int. So Java's telling you that this is a double and you're trying to do this math, which is gonna happen as a double. You're trying to force it into this tens place. Does anybody know what we can do to only get the integer value out of this operation? Okay. All right, so let me see, what can I do? Man, I don't know. Okay, well, I don't want to like keep making more problems, but what I'm going to do is I'm going to wrap my math because you want this to happen, right? And then you cast the result to an integer. Okay, yes.
Couldn't you issue something like the tens, 5 ones, quarters, doubles, and sevens?
You could do that, but then if you look at the output, and I take off points for this, or actually I won't take off. I'll take off points on your test. I'll tell you to correct it on your homework when you show me. But if you actually look at the output, it's telling you is there like a 0.0 at the end of this for? No, right? So what is it like? This should be an integer, right? It's not directly telling you to store it in an integer, but you could make it a double. But then at some point you're gonna have to convert it back to an int.
Okay.
Yeah. All right. Where was I? Wait, that's not the right thing. All right. So what's that? So putting an F makes it a float, right? And we're trying to put this into an integer. So like the only way to convert is to cast. And this is the way you cast. So now I want to hop over here and compile. It should compile, it does compile, and then if I run, I'll just say $47.63. And it's telling me I have 4 tens. Okay. All right. The next step of this was to figure out what my remaining is. Okay, and my remaining, I said it was equal to my amount divided by 10, and whatever the result of that is would be remainder. Now, remaining is a double, so you don't have to do any casting. But just to show you what the remaining is, let's go ahead and have. Actually, we should probably put the remainder first. Like every time we get the remainder, we should just print it out so we know what it is. All right, because we're just trying to debug to kind of see the state of our current data. Let me put this semicolon right there. Hop over here. Okay, so I'm gonna put $47.63. Okay, and there is my remainder. Okay, now, does anybody know what happened with that? Did I go over this before? I can't remember. So whenever you do any type of math on a computer, it has to convert decimal, which is base 10, to binary, which is base 2, do the math, and then reconvert it to decimal. So you'll have things like this happen. It can pretty much just be ignored for now, right? Like, I know it's not precise. If you wanted to use precise numbers because you're doing like true scientific equations, or you're actually working with money in a bank, then you would use a class called Big Decimal that is a part of the Java standard library. So we're not going to talk about that in this class, but for now you could just kind of ignore this. I wanted to show that this can happen, but you can just ignore. All right, so but that is the remainder. So the remainder is $7.63. Okay, I took off the 4 tens, and then the remainder is $7.63, right? So you can kind of see this working, right? So the next step was for the 5s. Okay, now before I continue, another thing that I wanted you to do is declare constants. So when you show me your homework and you have like a value like that hanging out in any equation, I'm going to say, come up here and make a constant like final int, and then you'll just call it like 10 value. And you just say it's 10, and then instead of using 10 everywhere, you just use 10 value. Okay, I know it's kind of tedious, but I'm trying to get you used to using constants. Okay, and we should go ahead and put in our 5 value as well, since that's the next thing that we're about to do. Now there is some coding standard names that you have to use whenever you're making these variable names. So whenever something's constant, it's all in all caps. If there's 2 words, instead of using the camel case, we're going to just use this underscore to space out the 2 words. Okay, so I'm pretty much just going to copy what I have here and paste it. Now it's not going to work because I do have to use the remainder, but I'm going to take this remainder, slap it here, change this to a 5, change that to a 5, and change this to 5. Okay, and it's going to tell me my remainder, and then I'm going to print out the number of 5s that I have. Okay, so I just copied what I did, but I just changed the values. Okay, and you'll see that. Wait, oh, thank you. Right here, thanks. And did I do that anywhere else? Oh yeah, I did. Oh shoot. Okay, save that, clear my screen, compile, and then run. Okay, now I'm gonna enter $47.63. And you can see that I have 4 10s, 1 1, and this is the remainder after I took off the, actually, no, my remainder's messed up. Did I do my remainder right? Is that right? Oh yeah, that is right, because you do have 2 1s left over. I was thinking that you only had 1 1, but I'm really bad at math. So you take off that 5 from this. So your remainder before was $7.63. You took that 1 5 off, and you're left with $2.63. Right? You can just keep going. I mean, like at this point, I mean, really, it's just copy and paste a couple of times. I'll just do that for the 1s and the quarters, and I'll stop there. I don't want to do your entire homework for you. So I'm going to come over here, and I'm going to slap in the 1 value. And the quarter value, I'll say QTR value. Okay, now the quarter value, actually I'm gonna have to move this to a different line, right? Because this is gonna be a double, and I'm declaring everything as an int. So I'm gonna come over here and say final double quarter value, and then have that as my quarter value. All right, so back over here, this is where I'm gonna do my 1s. So this is gonna be a 1 and remaining. Okay, and then the quarters, and this will be quarter value. Wait, that's wrong. All right, does everything look correct? I know I'm copying and pasting, so I can have a copy paste error. And now what I'm going to do is slap in the 1s and the quarters right here. I'll hop over here, clear my screen, compile, and run. $47.63. And that's correct, right? There's 2 1s and there's 2 quarters. Yeah. So let me see. Let me hop back to the problem. All right, so this is the output they wanted you to use. I'm using something a little different, so you're gonna have to change that. But we did the quarters, right? We got the 4 1s, the 1 to 5, 2 1s, the 2 quarters, 1 dime. We would have gotten 0 nickels if we would have kept going, and the 3 pennies. Okay, so when we originally read this problem last week and before I started this, it seemed like something really complicated to do. But like money is something that we use every day, but we just don't think about what we're doing in our head, right? So if you take time out to actually think about how you're going to tackle the mathematic parts of this problem, right? It makes it a lot simpler when you're trying to solve problems, especially when as the programming problems start to get a little more complicated. I would recommend just thinking about your approach, writing something down first instead of just coding. Like if I would have hopped straight to coding, and I was a beginner, like it would have been really difficult because not only am I trying to solve the problem, I'm also trying to remember the syntax, right? So there's two things that I'm facing there that I'm trying to think about at the same time. If I just focus on how do I solve that problem on paper, I can basically write instructions out for it and give it to somebody so they can solve it. If you do that part of it, then you just have to take that, what you wrote down, and translate it to your program. And then you can focus more on just the programming part of it. Okay, does that make sense? Okay, so pseudocode does come in handy. I will have you write some pseudocode. I wouldn't really worry about studying it, but on your test, I'm going to ask you a really complicated problem, like write pseudocode for a problem that prompts the users for their age. If their age is less than 18, you tell them they're a minor. If it's above 18, you tell them you're old, right? It seems like complicated because we don't know how to program for that. But if you're actually writing this out, like just the steps that you would do, you would say, okay, read the user's age, check to see if the age is greater than 18. If it is, print out you're old. Okay, if it's not true, then you check to see if, I guess there's only two cases there, right? Greater than 18 or not, right? If you're not greater than 18, you print out you're a minor. If it's greater than 18, you print out you're old, right? It's really simple. I mean, I know we haven't learned if statements yet, but you can write pseudocode for problems like that. Okay, it's actually pretty simple. All right, any questions on this?